in a previous video, I did the y is d squared y dx squared equal to the derivative with respect to t of the first derivative, dy dx, divided by dx dt, or x prime of t. So I did this whole lengthy proof thing in the first video, but I get that it's kind of hard to picture, and one thing I want to point out is that I would never expect you to recreate this proof to figure out the formula on a test. It's not a good call. This is one of those formulas that's kind of worth memorizing, but I just want to prove that everything I did mathematically is above board, so I'm going to walk you through this stuff, and then I'm going to plug in fake numbers to prove that the stuff I did with fractions works with this dx stuff and dy stuff the same way it would work if I had picked numbers instead. So I didn't break any math rules with fractions. So first we have d squared y dx squared, which is the second derivative of y with respect to x, which literally means derive with respect to x of the first derivative dy dx, right? So then I start doing some shenanigans with fractions. I'm going to slide this over a little bit so you can see what I was doing. So I said, hey, I could write this dy dx instead of the way I wrote it here. I could write it as that quantity over 1, and I'm going to show you with numbers in a sec that that's okay, but it's fine. For instance, if this had been a 3/5, it would be fine to write a 3/5 all over 1, because 3/5 is the same as a 3/5 divided by 1, right? And then I further went on to say that if I wanted, I could multiply this entire expression by 1 over dt divided by a 1 over dt, because that's like multiplying by a 1 collectively, right? Because it's something over itself. And then when I cleaned it up a little, I was able to make this d dt, meaning derive with respect to t, of dy dx, of that first derivative, over a dx dt, which is x prime of t. So, but I'm now going to kind of back it up with some numbers and show that this would work if I were doing this with numbers. Sorry for randomly throwing a pen across the board. So, just for argument's sake, right, let's call, just to show that my fraction logic is correct, not in any math sense where you should plug in numbers for d and dx and all that stuff. I'm just going to go ahead and assign some numbers here to prove a point. So, I'm going to call this we'll call that a 1, we'll call this guy a 2, and we'll call the dx's 3s, okay? And when I get to it, I'm going to use a 5 for dt, okay? So I'm just going to show you that the set of math I did, so what I'm going to do is I'm going to take that above stuff that I did, and I'm going to replace d with a 1, and dy with a 2, and the dx's with a 3, and the dt with a 5. I just picked 5 so that I would have all prime numbers other than 1, because it makes my life easier. Cool. So I'm going to show you now that I would end up with the same mathematical quantity. So if I picked 1, 2, 3, and 3, I want you to notice that if I had picked these numbers to start, this thing, if I had used 1 over 3 times 2 over 3, this would be a 2/9, right? We can agree that's a 2/9. I'm going to show that when I do all of this mathematical manipulation, the answer would still be a 2/9, right? So again, I used a 1 and a over 3 and a 2 over 3. Okay, so now I'm just going to copy each step I have, but I'm going to copy it with the numbers instead. So this is the same as a 1 over 3, and then in parentheses a 2/3 over 1. I think we can agree that just like 2/3 over 1 is the same as just a 2/3, dy dx over 1 is the same as just a dy dx, right? Okay, so that's this step, right? The next step says, take that exact thing, the 1/3 times the quantity 2/3 all over 1, right? And times it by, I'm using a 5 for dt, so 1/5 over 1/5, right? Cool. So now I'm going to clean this up a little bit and write it this way. So if I use my math information here, so my d was a 1, right? And I'm going to try and color code the same way that I did. So there's my 2/3. My dx was a 3, and then my over 5s, right? So I put this over 5, and I put this over 5. So this is this formula, but with numbers, right? Just to prove that it works. So I want to point out that if I simplify this fraction, it should simplify itself back to a 2/9, meaning that I didn't mathematically alter the expression. I just wrote it in a different way. So that's what's happening here, is that this formula is you manipulating the definition of d squared y dx squared so that you can rewrite it in a parametric form. And again, it's not something I would ever suggest that you do from scratch in the middle of a test. This is one of those things that if you're walking into a parametric test, you want to just know it. So if I clean this up, right, I'm pretty sure the top ends up being a 2/15, right? And the bottom ends up being a 3/5, right? When you divide a fraction by a fraction, you're going to multiply by the reciprocal of the denominator, right? So the reciprocal of this divisor, right? So I'm going to end up getting that this is 10 over 45, right? And it seems to me that I can cancel a 5, right? And when I cancel a 5, I get 2 over 9, which is what this original guy was. So again, essentially what's happening here is you're using the rules of fractions to write this expression d squared y dx squared as something else, and that's where the formula comes from.